welcome everyone to this session of Amplifying F#. Today it's Unlocking F# Potential, Tips, Tricks and Tactics, as it stands here, as it was outputted by ChatGPT. So it's not the rocket science, it's not the hard compiler stuff, it's not all the tooling stuff that we usually do. So today is just the small things, the things that are probably hard to notice, but once they are gone, you would really miss them. And we have, as our first speaker, we have Dave, who's doing some very top secret talk. I'm very curious on what you have prepared. Then we have Florian, who will show us his top 7 or top 8 or top 10 tricks in the area of F# scripting, which is really nice because I also love F# scripting. It's basically my, I don't know, 60-70% use case, and this is so to me this is a feature that is extremely underrated, because you can basically let me say, you can do everything with F# scripts. You can replace everything you have. You can replace your shell. You can, I don't know, even replace your hammer. You don't even need that. You just need F# scripts, and that's the turbo boost for the rest of your life. And then there will be me. I will talk about Vite. We already had some session, I don't know, weeks or months ago. I will showcase some things that you can do with it, some UI-related stuff, but also some other stuff. Yeah, that's the session for today. Just a small recap from the last session. It was what's new in F#8. And Edgar, I think you wanted to say something about that. There were some issues created. Some cool stuff happened after the session.
Yes, so last week we did a recap on what's new on F#8, and we showed some of the features like the error reporting that we added for static classes, or the tail call recursive attribute that David introduced. And yeah, so there is currently a couple of issues on the F# compiler with some enhancements on that side. So yeah, that's really good to see that there is people trying F#8, and there are actually good feedback coming back to the repo.
Great, very cool. Yeah, it's really cool to see the sessions have some feedback and have some impact on on the further development of the language that we all love so much. Great. So I would say, who wants first? Florian, you really seem to be so eager, but you're still doing some stuff. So maybe we. I can't hold the tension, David.
Okay.
So you are the first. Just unveil your secrets. I want to know what have you prepared. Show us your stuff.
Yeah, the secret is just that I had to come up with some last minute stuff. So, but yeah, I'm going to talk about some helpful things here and there, helpful tools, which can help you during tooling development, compiler development, just bits and pieces here and there. So over the last couple of days, I worked again on the compiler because some issues with the tail recursive analyzers have shown up. And the very helpful but super easy thing is to just do the build of a project with the compiler you are developing on, you are modifying. So in case people don't know, you can pass in directly on the command line the .NET FSC compiler path property, and it will use the compiler DLL. And yeah, while working on analyzers is quite helpful. You don't have to do the sometimes a little bit costly unit tests inside of the compiler code base. Yeah, that is regarding from depending on your context. That's quite a helpful thing here. The .NET FSC compiler path property. Next thing is most people will already know that one is SharpLab.io. Yeah, a large shout out to the makers of it. It's so helpful to have like a super quick way to see what type of C# equivalent or IL equivalent you get from a piece of F# code. Again, in the last couple of days, I used this for the tail recursive stuff. You can see here an example that Brian came up with. It's a dumbed down demonstration of a problem we had. Miroslav stumbled upon it. And yeah, you can see here, for example, that the match and the recursive tail call in the last case here is optimized by the compiler into a while loop. You can see it very easily if you choose the C# representation. And on the other side, if you give back a lambda function, a match lambda, the compiler is not able to optimize that one into a while loop, and yeah, you end up with a stack overflowing invoke chain, and yeah, it's just super helpful. Most people will know it, but yeah, I want to give out my large kudos to the makers, and yeah, if you find the time, it would be nice if you update some of the tools compiler versions.
Now, who's the maker? Who's the maker of these tools? Andrei
Shekin, Ahmed.
Kudos to Andrei. Yeah.
Yeah,
please,
definitely.
Please update your great tool, or ask somebody to do it, or show us how you do it. What about that? It would also be a cool session, probably.
I think there were pull requests to update, but yeah. Okay, next stop is the binlog. Also known, I'm pretty sure, by a lot of people, but still super helpful. If you do your build with the /bl, a file will be created called, in the default case, MS-build binlog. If you install a viewer for it, you get more details than you might want, but at some point you need the details of the build. Just MS-build details en masse. Yeah, if you can't get enough, yeah, here's your fix for it. You can do a real deep dive into the build process, like basic stuff of the environment variables, but also deep in the trenches of your yeah, of the tasks that are done here, and yeah, it's just great to be able to get to all these details, and in the past it has helped us quite a lot to debug issues, to understand some stuff, and yeah, if you deal with MS-build or build processes, if you do benchmarking of the build and all that, yeah, really helpful stuff. And yeah, there's also a plugin for VS Code if you prefer to work in there. But yeah, this structured log viewer is already pretty good, I think. Okay, next stop, NuGet.info.
Just a small question, if I'm allowed. So
Sure.
I mean, how so usually, okay, use case would be, I get an error from MS-build and I don't know what's going on. So then I can switch to this tool or the VS Code tool and have a look at the bin log. But so what's the burden to get into this? I mean, is it possible to get into it quite quickly, or do I have to I don't know, attend some rocket science sessions to be able to understand it and use it, or what's the feeling about that?
Well, you can make a call to Florian, and then you have the wizard of MS Build at your hand. And yeah, I think you will be very quick. If you have no prior knowledge of MS Build, it can be a big kind of a steep learning curve, at least in my experience. So, but yeah, maybe.
So,
maybe it's a talent thing, and other people are quicker in understanding MS Build.
no, same for me. It's doable, but it takes time, and you have to get used to the thinking of MS Build.
Yeah. Okay.
Whatever
I'm glad
that's
I'm not
supposed to
alone.
mean, we have to get used to the thinking of MS Build. That's very interesting. I would like to know more. I would like to know more what that exactly means. But maybe in another session, in an MS Build deep dive, for example.
Oh, that sounds like a job for a certain member. Okay. Next up is NuGet.info. If you're dealing with packages, if you create packages, this is also really helpful. You can basically select any NuGet package from the feed, even if you're in NuGet.org. That's pretty nice. You can go to some package and yeah, open the NuGet package explorer, and that will bring you to NuGet info. And yeah, you can just evaluate that the things you think will end up in the package are really there in a little bit nicer, more user-friendly way than unpacking the package yourself and looking into that. Yeah, you can see how the internal structure is in the package, what the users will get. Yeah, the metadata is there, what kind of dependencies you get. And also a pretty nice thing is that you can upload the package. So if you have created a local package file, you can upload it here, like this one. And yeah, the tool will present the internals in a pretty nice way. And yeah, that has also helped me in the past here and there to understand some issues I had with NuGet. All right, so I showed here the FATS package, and there's some news I can showcase. So if you followed along the last couple of weeks, you will have noticed that we worked on analyzers quite a bit, and maybe you end up with quite a lot of Serif files in some directory, and you want to get a quick overview, and these files are not the best one to read by your own eyes. So I added a little bit of FATS support to get a quick overview about the code that is analyzed. So you can see here in one glance what the analyzers are talking about. So here you can see that this line of code is in the warnings, and you can jump straight to it and see that, yeah, there's something to be improved with this statement. So if you like to work on the console like me, and you're kind of quick there, you can use that one. Of course, there was Serif viewers, plugins, but yeah, for me it was quite helpful to get such a quick overview in the console. All right, another topic. I looked into other languages in the last couple of months for various reasons. And one of the languages was Elixir, and Elixir has a pretty nice experience regarding the REPL. So if you have a question about, as a newcomer, you have a question about some function, and usually as a newcomer, at least I always go to the REPL first when I interact with a language, because it's like quick feedback loop and you get a good quick feeling for the language. And Elixir is the super nice feature that you can just H to some function and you get this really nice output. You get the specification, the signature, you get some browser text and some examples how you can use this. You can just copy the example and try it out, and that's a pretty good experience. So compared to what you get in FSI, you can do something like this, but that's about it. And the newcomer, has to do a context switch to the official documentation, look up the function, and that might be not the best experience for newcomers. So it would be nice if we had something like the H function. And it turns out my FSI has this H function, but it wants a quotation expression. So let's do this and see what we can improve here. And it turns out F# can do that as well. You can get the full name.
I love you. I love you. That's really great.
You can get the full name in case you want to do a deep dive into the implementation of the function. You get the browser and the parameters, the return explanation. You get also the example for the newcomer, always very important. And this is quite helpful, I hope. At least you can do something more involved, like the foldback, because the foldback is a little bit more complex. Also, the explanation you get is more deep, thanks to the people writing that one. And as you can see, these are now functions from the F# core, but of course it would be cool if you can do that with any NuGet package. So let's try that out. A package I can really recommend in the last couple of weeks is the Analyzers SDK. And let's try one function from the Analyzers SDK, like there's this Walker TAST, pretty much every author will use. So I hope every author will use for the analyzers. And if this all works out, we should be able to get the same. So you see, you get again the full name and the summary, but because the authors haven't written examples or deeper documentation, you only get the summary. But that's a good heads up to the authors of the SDK to improve that one. And that's all I got for today.
Wow, that's really nice. That's really nice.
One thing. It will be released, because I'm still working on this on the 25th of December with Sergey's beautiful F# advent calendar. There's a lot of ideas. I mean, you can reach out to some web service if you want to more examples, you can query some search engine, some AI service to come up with more examples for the code and all that. So I can imagine that we can really improve the FSI experience, because we have fallen a little bit behind the competition if you see what other REPLs can do. But yeah, let's catch up to them.
Very nice. Question.
Yep.
In principle, it be possible to do that without the quotation?
So far, I haven't found a way, but it's very early in development. So I hope I can come up with something better. But yeah, it might stay like this. You will see in the at Christmas 25th.
You could maybe make use of a computation expression, because you are able to compile the expressions to quotations per default. But okay, I don't know if that would be more helpful than just dropping it in a quotation manually.
Yeah, there were lots of ways I haven't fully tried out. Like currently it's processing the XML file, but I also had an implementation which made a web request to the web pages of the documentation. But it turned out to be more reliable to using just the XML file directly. I had one implementation which tried to go to the GitHub sources, and yeah, currently the most reliable is the XML file itself. So, but yeah, there's still some time to try out some stuff.
Yeah, David, thank you very much. There was a very nice set of useful things. Yeah, I really like the point of improving the REPL or F# interactive, because I mean, as Florian will show us, it has so much potential, and yeah, you sometimes it's just really the imagination is the border that you have, and not more. And I think it's really valuable to just think, okay, what could it be? What could we do more with it? And yeah, and go for it, because it's also such a low barrier experience for newcomers in the language. It's really like, hey, you just need that, you just need INET VS Code, and then I don't know, just hack your stuff into an FSX file. I like that idea very much. Thank you, David.
Thank you.
Great. So next part is my part, I guess. Florian, you are still hacking, or?
No, I can present as well. I mean, it's all fine. If you want to go first, yeah, you decide. Go for it.
Okay, then I go for it, and you close it, with our stuff. Wonderful. Yeah. So today I will showcase some of the Vite stuff that I did. Maybe you can remember. We had a session which was called composing state-aware functions, and I will not go into that very deep now, but I will just try to recap the idea, because the idea is important in order to understand what can we do with it. Because today I will show what can we do with this composing state-aware functions. So we'll just make a very big circle now, and I will just recap how it's working. So the idea is we have a computation, and that computation is made up of pure functions. But these pure functions, they retain their own local state. And this local state is just fed into a function. It's just an argument of the function. And then once we have evaluated this computation, we just get a pack, a bunch of all that local states we have in the computation packed together. And then we can re-evaluate that computation just by feeding this state pack unwrapping it and sorting it into the right local pure function, re-evaluating it, grabbing all the state, packing all the state, and when the computation is finished, we get a new pack of state. And this goes on and on and on. So it means we have a computation. The computation is re-evaluable over and over again by feeding the last state in the right functions, grabbing that state and repeating that stuff. And this is basically it. This is the whole idea of these composing state-aware functions. It's not objects, so there are no objects involved, basically, which gives us some advantages because the computations that we write, they look very, very clean. Yeah, so there is no instantiation, and the evaluation is just the function sits there, and we can compose them just like normal with our things that we compose them normally. And now if you take this principle and you ask yourself, what could we possibly do with that stuff? Then you quickly understand you can do a lot of things in many domains. You can cover with this principle, and if you look at the domain of user interfaces, this works, or this can be seen as user interface may work somehow similar to what I've just explained. So because it's like you have user interface, the user interface is made up of different smaller parts, but just from its nature, these smaller parts, they have local state. Yeah, so the text box, it retains its own state. It has some text put in. Yeah, and I don't know, you have some graphics, and it has some state. It's green or red or whatever. And this is this feels very natural. And the UI, the user interface, we can now see, and we all, or probably many of us, know it from frameworks that are reliable and working very well out there, like React or Svelte or something like that. We already know that. But the UI can be seen as a computation that is run over and over again. Yeah, and it just updates itself. Yeah, and when I click a button, all the UI is evaluated again. It changes its state, and I can see it as once the evaluation is done, all the state I have here in my hand, and I can put back and re-trigger the evaluation, for example, when a new or another event is happening in the UI. And how that looks like, I would like to show today. So that whole thing is called Vite. It is not only for user interfaces, but it is it is also for other things. But now we'll have a look at the user interface part, and there are many implementations. Vite basically works for Avalonia, as we can see here, and it is working pretty well in F# Interactive. And we'll just have a look at how this is going. So first, there are some NuGet packages, some Avalonia packages, and some Vite packages also for Vite Interactive. I just have to evaluate them, and I have to do it once. And once I did it, we are set up. We are set up and ready to rumble and to do some cool stuff. So I will just have to move away all the Zoom crap. Okay, so I can now bootstrap a window. It's just an empty window that I have here. And now it's a very famous thing. I think it's the counter app. So in Vite, I do it like this. It's a computation expression. It's a nested computation expression. I set up some states. We want to have a counter that we can increment and decrement. And the counter is basically a value just starting from 0. I have a function where I can change this counter value. I have a stack panel. So to people who are familiar with WPF, Avalonia, or Maui, they know this stuff, stack panel and so on, I guess. Otherwise, I think it's self-explanatory. So we have a stack panel is vertically aligned at the top, and we have a margin, and the stack panel itself, it has children. So the stack panel itself can have content. And we have a button. The button is clickable. And when we click on the button, we just invoke the add function, and we decrement our counter value. We have another button to increment counter value. We have a text box, a text block that can display a string, and we will just say, oh, okay, the count is, and then we just put the count value that we that we are modifying. This is basically it. So I can, evaluate this piece of code. And we see we have here our two buttons for increment and decrement. We have our text block, and now I can play with this, and it's working as expected. Yeah, it's that easy. I can also, I could also do now other things like I can easily, for example, just as an example, I could easily make a component out of it. I can call it counter or count what, the subject, and then I could say something like this. And now I would like to use this counter component that we just did, and I can say cats, and I could also do like this, cats and dogs, and hopefully I didn't try it, but hopefully this will work. So we can count cats and we can count dogs. Okay, wonderful. This is so great. Yeah. So as you can see, so Vite does some things very easily. So there are no heavyweight components or no objects, no classes that you have to implement somehow. It really works. So it really has functions and composition in mind. That's it. Yeah, that's really the focus on all these things. Yeah, yeah, that was a small demonstration on how we can just factor out components and use them just in a very, very easy way. But there are also other things we can do. So, for example, here's a to-do list, because Vite also focuses on using the idiomatic things that we have in our language in F#, that tries to enable them and to make them usable while you are coding your user interfaces. So, for example, we see this. We have a to-do list. Maybe I just evaluate it. So we have a second window. So the to-do list. How does it look like? We have a heading. We have some items that we can check or uncheck. We can add a new item. We can add another item. We can check these items, and we can remove them. That's the way the to-do list is working. Why is that a nice example to showcase? So the to-do list, basically, it has a model, is a list of to-do items, and the to-do items, they have a text and it is done. And we can, for example, just use a for loop down here, where we just iterate over our current to-do items, and we can then, for every to-do item, just yield basically the UI for the item. This is very easy. We don't need any new constructs like for example in Solid.js. They solved it very nice, I think, but we already have a for loop. We already have a for loop in F#, and we know this construct, and we would like to use it. We know it in context of lists and sequences or other things, and now we just redefine it in the context of our user interface. And this is I think very easy to use and to understand. You don't even have to think about it, because every one of us knows how a for comprehension works in terms of lists, for example. Yeah, I don't want to go too deep into the code, because it's quite self-explanatory. You can find these examples in the Vite repo, or also in the repo that I created today. It's called Amplifying F# Showcase. This is quite easy, but there are also other things that are quite interesting, and this is because Vite isn't made for Avalonia. We just use it. We just use it in context of Avalonia, but it is built basically upon nothing. So Vite is technology agnostic, which means we can easily adapt these things that we have seen here, which is basically you have a node, a tree, yeah, a node-based model, and you can use it for your own stuff. And I use it for Avalonia, but you can also, for example, use it for Maui, which is basically the same thing, or you can also use it for completely other stuff, for example, for Fable. And there's also a Fable version of Vite, which looks basically like this. So this is the Fable version of the to-do list. This looks very similar, but just in this case, we are dealing with HTML elements. So we have a div instead of our stack panel. And yeah, I mean, you all know that stuff, but basically it's the same idea, and is very close, but it does not hide anything from you. Yeah, so we are doing web development. In the other file we did Avalonia development, but the ideas are completely the same. Here we have our for comprehension, yeah, and we define our state up here, yeah, our to-do list, and so on. So this is basically, once you understand one thing, you understand everything. And just as a small proof, to see how this is working, I just compile the Fable app now, and let's have a look if our to-do list is running as we expected. I love Fable. This is so great. Fable was also the first thing I did for Vite, and it's so cool. Really, it's the best thing that happened to F#, except F# itself, of course. Yeah, so here we have the to-do list, and yeah, it's basically working the same way as we have seen in Avalonia. We can remove that stuff. Yeah, so it's quite technology agnostic, I would say. And it's very easy to roll your own thing, but we'll come to that later. Yeah, let me have a look on my list. What's next? Yeah, there are some more use cases for that in the Vite repo. So because there are there might be some interesting abstractions, some demos which I would like to show here. These demos, they are working in Fable, but they're also working for Avalonia. Yeah, that doesn't matter. For example, you can have components that emit values, which can be quite interesting. So what we have seen before, that wait, let me just do it here in Firefox. And yeah, for example, we can have components that emit values. This is a thing that I find quite interesting. So because just imagine we have a counter, so we have a counter component, but we would like to have the counter component that emits a value. It emits the counted value, and we can do that just by returning that value. So when I increment these values here, I have here the counter component. Here's this part, and we just use the value that we have emit to display it below, which is this. We have here our component. We just say, okay, we have a counter, we have an increment and a decrement button, and we just return the value of the count. And then we can let bang this component, which is a little bit, looks a little bit strange, because the component itself causes side effects, because it will render in the view, and it emits a value. You can now say, oh, you should never do it, but I'm always for these practical things. And I think in that case, it's perfectly valid, because the side effect is made in a complete different layer. It's just a UI side effect, but now I'm on another layer. I'm interested in a value that is returned by that component, and yeah, this is also working, as you can see here. What else do we have? There are some ideas that I had how you could cope with async. So I won't go too into detail of that, but it's possible. So async somehow is supported by this library, and you can, for example, say, okay, I have several wait stages for in my UI, and only when that is done, I would like to proceed. In this case, we just add new content to our UI, but we could also clear the content of the UI. This is just not part of the example, but it would be possible. So we are just waiting a value, and once we have the value, we just continue with our UI. And we can just see that here. Loading first number is 42, loading second number is 187, and so on. And now we are done. This we can also do inside of an element, and to have some kind of parallel processing, basically. This is it's this. So we have inside of an element triggered just in parallel, and we can also return values from our async computation, which we can then use to display a text. This was basically it was this example that we just had a look. So there are several helpers, I would say, several use cases which are supported. If they will work or if they are really practical, I cannot tell, but they are just the ideas are implemented. And there's a lot of other things that you can do. This is just a demonstration of how you can use Byte as so if you want to program a UI in Avalonia or in web. I would also like to pinpoint some facts that might be interesting. So it's basically, it has 0 dependencies. I already told that. It's very lightweight. So and technology agnostic. So for example, if you're interested in how does the Avalonia layer, or I wouldn't even call it a layer. So I would say it's more like a bridge. So you have, so Byte is one stamp, and you have your whatever kind of technology, like Avalonia is another stamp, and there's just a bridge, a thin bridge between these technologies. So for example, if we have a look at how is the Avalonia bridge, how is it implemented, is basically is not much. Here are some. Here's a little bit of code you can do to help yourself. It was just 100 lines of code. Then you have some convenience functions over here. Then you have the auto-generated API. Yes, this is quite heavy. This is 5,000 lines of code, which is basically SRTP and extension methods over some known Avalonia controls. But this doesn't. You could also do it other ways, but let's stick to this. And then you have also followed up on this some other convenience methods, just also 150 lines of code. That's basically it. So implementing a a MAUI API would just be, I take my code generator, do some tweaks, and I have it basically. So it's a very thin bridge. And also, Vite does not hide the underlying technology from you. It's always possible to get directly to the UI element and do something with it. Yeah. So it's more like an opt-in, and you can plug it in everywhere in your UI tree, or just exit it everywhere you want. So it's not a do or die, but it's really like, okay, here I need it, here I want to have some Vite, and then you just plug it in and use it. Yeah, it's working for Fable and .NET. You can also easily adapt it to other domains, for example. I mean, here we have the domain of user interfaces for various technologies, but you could also say, hey, the idea of having something that is re-evaluatable, yeah, and made up of functions that retain their local state, this applies to many domains. So, for example, we can do some signal processing basically. I have also prepared something for you. So signal processing, as we can see here in this wonderful picture, is basically really you put in some values, you compute them, and you have an output value. Yeah, that's basically it. So yeah, you could also call it stream processing or sequence processing or whatever. But only that you can basically process. So you can think of it like you have sequence. Yeah, you process values in a sequence, but in the sequence comprehension, you cannot process multiple sequences element by element. But here you can do it. This is a flip around. And how does that look like? Now, for example, I have this IronPython notebook. I would like to plot some cool stuff. Here I have some helper. We can go over that, but it's about audio processing. So I want to do some stuff with audio. And what I can do is, for example, I have a generator. It's a sine oscillator with a frequency 30 Hertz. And I have another oscillator with a frequency of 7 Hertz. And now I want to modulate. I want, so the second is our modulator and the first is our original signal. And I would like to modulate them just by multiplying. So it's, what kind of modulation is it? Is it a frequency modulation, amplitude modulation? Oh man, this is many years ago. If anyone knows, feel free to tell me what kind of modulation this is. But anyway, we can see what it does. So I play it and I can plot it. So maybe if I just plot the first oscillator, we'll just get this wonderful sinus out of here. And I mean, I can just also plot the second oscillator. Is much slower. It's just much slower. Yeah? And when we now modulate these two by multiplication, yeah, we get this. This looks really nice. Yeah, yeah, and basically what it does, it is you can see this as a sequence of values, and you can see this as a sequence of values, but we pull them piece by piece. Yeah? We just pull them piece by piece, and we have every single value available in one evaluation. And then in the next evaluation, we have also piece by piece, we are pulling these values. Every single value we can then have in our hand and do something with it. Yeah, and we can also, for example, make a second modulation just by having some noise. Now we can apply some noise to this thing, and this will look wonderful. Just like this, we just have some heavy random noise here, and we can then, for example, because until here we only have generators. Here we are just generating a signal out of nothing, basically. But we can also say, okay, we want to process a signal that is already there, which also means there is a lot of state involved. Yeah? So we have a filter. and a filter needs values from the past. Yeah, this is physics. Yeah, it does not work differently. A filter cannot work without knowing some facts from the past. Yeah, and we can do it here very easily. It's just it's the same principle. I can now say, okay, we have this noisy modulated signal which is here, and we plot it, and we have another plot. We have the noisy modulated signal. We apply a low pass filter to it, and we plot it. So we get two plots. I mean, also I love plotly.net. I mean, this is really so great. Yeah, we all know and love it. This is the go-to library if you want to impress some people with nice graphs like this, like I try to do now. So I just play it. And it's working, you see? So the first is our noisy modulated signal from above. It's the blue one, and the red one is a low pass. So which basically means we just put out the noise again, because the noise, you know, is statistically, they are different kind of noises, yeah, but we just filter out the noise. We just let the low frequency pass, yeah, and everything that gives us like a very high volatility, we just filter out. And also we see a little phase shift. I mean, just for the people who are interested in making sound and audio, we just see a little phase shift. So we have a low pass filter with a phase shift. Okay, it's not so super high quality stuff, but who cares? Yeah, that's basically it. So we can use the same principle, yeah, the same principle with these multiple evaluations, feeding the last state into the computation piece by piece, grabbing up the state, repacking it, and doing it again. We can just basically do some analytical stuff like we did here. Or we can, of course, we can also play it back. I don't know if you will be able to hear it, but I try. So, okay, now I start the playback. Okay, here we go. Could you hear that? Are you there? Are you still there, or am I talking to?
No.
I think you have to play with your audio stuff in Zoom to relay that to the session.
Yeah, maybe I won't do that because once my setup is running, I will not change it because it's very very fragile. I have a very fragile setup here. But okay, you can also try it on your own. Just clone the Vite repo, go to a Vite audio, an audio source, so you can see it here, yeah, and just play with the playback stuff, and you will get a wonderful sound out of it. Yeah, it's of course all a matter of taste, but I like it very much. Yeah, that's basically the things that I wanted to show today. Or do I want to show more? Yeah, maybe one last word is maybe one last word is like yeah, you can easily take these things and apply to your own domain. For example, I have ideas for a workflow engine, yeah, so that where you can define steps and you can really persist these steps and wake the whole computation up. I don't know, after 1 year of sleeping or something like that. This is also possible, just to persist this whole state package anywhere, and then having some mechanism that wakes it up and retriggers it after a long time, for example. It might also be possible to do some for some simple games, to have some React for game development, basically, yeah, which could be a really cool thing if you do not do AAA stuff, of course, but very small things, because performance is always a question. Yeah, yeah, but I think that there are quite some things. It's cool thing that you can just use and play with it. Yeah, you can just play around and I don't know, go in F# interactive, play with Vite for Avalonia, or do some signal processing stuff, do some audio stuff with it. And yeah, I hope that that it will continue to live. So contributions or ideas or whatever is always very appreciated. Yeah, that's it. That's it from my side, ladies and gentlemen. Thank you very much for watching.
Thank
Any
you.
questions?
No, it was very nice to see the examples. That makes it much clearer what White really is about. Thanks.
Thank you.
Thank you, Bernal.
All right. Unmute. Now we have Florian with his, I don't know, is it top 5, top 7, top 10 F# scripts
top
in daily?
top 6.5 maybe, I don't know.
Top 6.5. Okay, Florian, I'm really curious. So you have the word, and let's go.
Yeah, I really didn't want to oversell this, so these are just things I use, I guess, in scripts. Not all of them are so impressive, but just want to walk you through a couple of things. So first, and probably the coolest thing is like the cool cat cracking, which isn't a real thing, but this is how I call it, and it is a way to get F# compiler arguments based on some new functionality in .NET 8 from MS Build. We'll go over it real quick. But I've written a piece of code, and I just want to explain a couple of things that I just frequently interact with. The first thing would be CLI wrap. That's just an interesting NuGet package where you can, wrap command line executions as a task. And yeah, this is actually pretty popular in the more general .NET community. So it's written in C#. It's something just goodness from .NET you can use. And what I'm basically interested in doing is running a .NET CLI command, and I want to run a bunch of targets and pass in some properties and eventually get an item. Now, what is this get item stuff? Let's maybe take a look at that first. So when you have the .NET CLI over here, there's a lot of things we can do with that. And one of the things is just also go and execute raw MS Build executions. And in this case, .NET MS Build is going to evaluate my FS project over here. So I'm inside of a project. I have a typical FS project over here. And what I can do is I can say .NET MS Build get item project reference. And then it just grabs the MS Build item from the evaluated project and tells me like, hey, this has one project reference. It is Phantoms FCS. If we take a peek again at the code over here, it also like this is this project reference that you can just invoke an MS Build command. You get the item from the command line, and then you just get JSON, and that just opens so many doors. So I'm actually really excited about this. This is probably for me like the cool thing in the .NET 8 release. And maybe another thing like reference assembly. Give it a quick check. So in this case, I'm gonna check, does this produce the reference assembly? Let's assume I actually don't really know. I can get the item, but in this case, it's not an item I'm after, it's the property value. And then yeah, you get the reply. Like it does all the goodness of MS Build, but you can do it outside of process. And to do it outside of process, but from a script, we're going to use CLI wrap. So instead of typing this everything over here, we're just going to run it inside of our script. We can easily say to CLI wrap what is our working directory. So in this case, I'm going to pass in an absolute path to an F# project. That's the parent is going to be the working directory. I'm going to run MS Build. I'm going to invoke a certain set of targets. This is a long list, and it is basically doing a couple of things behind the scene that happen when you do a .NET Restore. So it does a little bit of other magic, which I wouldn't overly go into. But this is what we call project cracking. It is the set of targets that we use to perform a design time build. And the design time build in .NET is doing all the MS Build magic, but skipping the actual compilation. So you do all the steps up until the point where you have all the information to actually do the compilation. We call the F# compiler FSC invocation, but you're not gonna do it, but you still have the arguments. And that's sort of the cornerstone of tooling. It needs to know these arguments before your editor can sort of light up and give you IntelliSense, because it needs the same information that will happen if you would do a .NET build. Now here, I'm going to run a set of targets. I'm going to give it some properties, and then I'm going to ask for it to give me the item FSC command line args. And this is basically going to be the equivalent of the compiler arguments. Then I can do a little bit of JSON processing where I know that I'm going to have a root with items and then the thing that I'm after. This is going to be a list of a bunch of things because it's an item. Because it's an item itself. It sort of has some metadata, but I'm already really interested in the identity property, and I'm just going to run this. And sentiment is not defined, so not quite sure what's up with that. Maybe I didn't get everything. There we go. That explains. So I have a couple of things in the script. There we go. So it's really subtle, but these are all your arguments. These are the references that come with the with your default.NET SDK. So that's the -R stands for reference. It tells me which defines are active. So by default, that's debug, but also it looks at what kind of a target framework you have into account. It's going to say, hey, if I produce binaries, which it didn't do, but just if it were to compile, it would compile to this output location. So yeah, this stuff just really is gold. And I can imagine this isn't really practical for a lot of users of F#, but if you need to do anything on the tooling side, this is really so valuable to get the correct arguments. And if you then pass these to F# project options and you go into the compiler service, and that just really is all the information you have about a project. So it listed all my files over here. So just to do a bit of a comparison, if we were to do a build and say verbosity, normal. So this is a build, and you can see this is a very similar view. It's a different project, of course, but it is a very similar view of what for compile is actually going to be executing. So this is .NET passing in the compiler program, and then it gives all these arguments. Well, this is just the script we ran gave you the same thing. It didn't produce the binary, but it got you the same arguments, which again is very useful for anything tooling related. So super happy that this feature got added to .NET 8. And yeah, this is really eventually it will land in stuff like Einheit, and your project restore will be so much more reliable because it's so much easier to do. So yeah, it's really stuff that gets me excited. So in the second example, another thing I frequently do is download new .NET SDK, and we're going to do this with FSHTTP. There is a link that changes every day to get like the new SDK. In this case, we're looking at the 80200s. That's going to be released somewhere in February, I assume. And if we grab this, we're actually going to do a head request. So we're not going to download the SDK itself, we're just going to look into the download URL, because this AKA MS URL will just on a different basis lead to a different actual download URL. Sometimes it's not that daily. Like there could be some day passing where no new SDK was published. There's something to take into account. And in the first request, we said, hey, we're only interested in the headers of the response, so not the actual binary. And we also don't want to do a redirect. That's the default behavior of the HTTP client. Like when you serve this URL, you will get redirected to actually this URL, and we don't really want to do that. We just want to get the response, and then the response is that this is a 301 moved, but yeah, the location of the response is what we're after. I'm gonna download this into my download SDK folder. I'm going to extract this based on the name of the zip. But of course, it could be that, we already have the SDK downloaded. So in this case, it's that already extracted, which means like the thing I downloaded yesterday, there's no new SDK produced. If this happens too often, it's a bit of a red flag, like the .NET SDK nightlies aren't being shipped, then maybe something is blocked, and then it's worth looking into the .NET SDK repository to see what's up. But in this case, we just extracted the whole SDK, and if we then look into that extracted folder, there's going to be a .NET exe there as well. Actually, maybe show you that. I'm just going to grab this, do like an ls, and then this is pretty much what you expect when you look into the directory. Host, SDKs, whatnot, and you have a .NET exe on Windows, and when we then run that exe with like version, it should tell us that it downloaded a 200 preview version. This is very interesting, and they can really use that SDK to compile your own project, and doing that with a nightly frequently just gives you confidence that once 200 official gets shipped, you're still able to verify that, this is going to work for my code base. This is just something I frequently do. And I really like, using little things like the HTTP downloads and, again, CLI wraps to execute binary files. Another thing that's sort of related is just copying stuff to the clipboards. I'm not quite sure this works on other platforms as well, but if you're on Windows, the text copy thing will just basically has this clipboard service. You pass in some strings that text, very straightforward, but I really use this quite often, and then I make a little script. In this case, I had a coordinate which I want then returned to a React component, and I mapped a couple of coordinates which I had. So I had like a GPX file processed, and then eventually just want to have markers to paste in my HTML because that was a static bit. And in this case, we're just doing the set text from clipboard service. So again, nothing special, but I really use this a lot. Another thing I frequently use is Toph. Toph is a library to decode and encode JSON. So in .NET, you would typically, whether you're using Newtonsoft or System Text JSON, you typically map things to like a class. But I don't really like that, because if you map your JSON to a class, then, well, the moment you start refactoring, or it's all very brittle. If your JSON structure changes or vice versa, all of a sudden it's all a little bit on reflection. It's reflection based, and then things will go wrong at runtime, but you never really know upfront. And that's why I'm more a fan of trying to decode JSON, as in I expect this is what my shape looks like, and give me a result, whether that's going to work or not, versus just expecting that this produces a float. So I'm opening the namespace. I'm going to say decode object. So I'm expecting an object, which is what my sample represents. And with this get function, so this get object allows me to say, hey, I'm expecting a required field. It's going to call it, it's going to have lat as a name. And I expect when you try and then decode it, it's going to be a float. So the moment that my lat is not present, the thing is going to yell. The moment it is not a float, it's also going to yell, and it's going to tell me exactly what kind of happens. So we'll run all of this. Then this is going to say that I decoded the coordinate, so that's good. But the moment I make something else out of this, so let's say I make a string out of this, try that again. That's going to say I expected a float, but instead I got this value. Or the moment we try and rename this fields, it is also just going to tell me that I was expecting an object with the field lat, but this is the object I got instead. So it's just a way of dealing with a lot more safety when it comes to JSON. And when writing APIs, you typically do not trust at all what you're getting. So I don't really want to, some reflection magically creating a class that I once wrote at a time to figure out that that's what's incoming from my request. It probably isn't. So I just really like the level of control you have to really define what you have. Writing these takes a little bit more time, and I kind of understand the sentiment that, yeah, the other thing is just more convenience to create your type and then let the magic work. But I'm a sucker for this. I really like doing this manually and having that strict level of control, and also having that clear error message like, hey, why is this JSON not decoding, not parsing? Next up is, I guess, the most boring of example. I frequently just read all the lines from a file. I do something with that. So in this case, I just trim the end and I write it back out to a file. This was an example where I just wanted to touch some code that wasn't automatically formatted by any tool. And I just wanted to trim the lines in another PR first, because when I touch it, I want to have like the most minimal diff. And I just trimmed the end of the lines because it wasn't happening automatically. And yeah, this is just something that's very convenient when you need to change a file from like an old format to a new. You just go over it line by line, just a little bit of parsing. You typically map the line to something. If the condition doesn't apply, just return the original line, throw them back in, and then just get like the same file but cleaned up. Another interesting thing is formatting code programmatically with Phantomus. So as you probably know, I'm one of the maintainers of Phantomus, and from time to time, people report issues with old versions, like, hey, it was working over in this version, but it's not working in the new one. And yeah, I mean, it's always a little bit doubtful, and you can format your code with older versions in our online tool. So that typically covers it, but sometimes people are very persistent, but hey, no, it was in this exact version and it broke. And then I'm like, okay, doubtful, but by formatting programmatically from within a script file allows me just to pin the exact version the report is coming in, and then I can basically execute this and then see that the string was formatted like that in version. So I don't really have an example of where this could go wrong, although let's just try something over here. Maybe won't have the comment afterwards. It does. Okay, I didn't super think this went through, but it does happen when these things are lost in translation. In older versions, it's not working. And yeah, then it's just easy to then bump this version and see when it started working or where it stopped working, and have a little bit of more fine-grained control of when the bug was potentially introduced. The last thing I want to talk about is using script in F# formatting. F# formatting is a tool to write documentation, and I've been working on the tool quite a lot the last week. And one of the things you actually can do with this tool is write F# script that then transform it to HTML for the documentation website. And it's really one of the main reasons you would want to look into the tool altogether. And let me just try and give you a little example of that. I'm in the Telploon project, and I am going to run my documentation servers. So this little script here, which has a special pipeline called watch, and that will launch the tool itself. The script is actually what I sort of consider the spiritual successor of Fake. This is a script written with fun.build. Fun.build allows you to have like a DSL of pipelines and stages, and you can easily either just run commands like this, or run custom functions where you do some custom logic. Works really well, it's really concise, and it just allows you to easily run something on your local machine the same way it's going to be ran on CI, and having that just, yeah, is very convenient. Now, over here, the documentation site launched. And let me try and put these side by side, see if that works. All right. Let's take a look at all files, and in the documentation, let's create a new script file. Now, before we do that, we probably want to, let's say, X, and we can do like a bit of a mix between writing Markdown in code comments and writing actual F# code. So let's write some F# code, and you'll see what I'm talking about. This should have created a test HTML, which it did. That's how I can create my Markdown over here. There we go. We have live reload. It's very good. And the interesting thing you now want to do is actually reference your local DLL, which could be something that you build up front. So in our case, let's just go up and then try and find some binary. Hope this exists. All right, Helplink core. So we loaded it, and now we can open up Helplink core, which is a project, and see if we can make signature. Check the API. Signature creation, something. So signature creation now has two methods and two functions. Let's take a little bit of a peek. Let's actually create something new. Just call this add for now. Let's just write a signature. And the clue is that we're going to we'll need to stop and reload this, but we're going to create our add function over here and do quick builds so that the yes, so I added it to the signature, and of course I add an implementation for it. So let's say add A and B, what you think it does. There we go. And build that again. 1 and 2. Okay, so 1, I can just evaluate this as a normal script. Say so. There we go. And when I run the tool back again, this will update, so that's all fine. But what I actually want to show you, and one of the reasons it's very interesting to use F# formatting, is that you can allow this to break, to let the build break if the script no longer compiles. So what we can do with fsdocs is say, let's build the project. So in the build script, we're doing the watch mode. We're now just doing the build mode, which is going to evaluate everything. We're going to say eval, we're going to say clean. And we're also going to say strict. This is going to compile this file into like an HTML. So it's copying, and then over here we should have some sort of an output folder, which has my docs folder and has the test HTML. And then here, all of a sudden, we'll see something let A, or just call let. And then a little further, we'll have the other things 1, 2, so that that matches my script. But now the thing I really want to show is what happens when we update the signature. Let's say this now takes a string first. We update our codes, and everything's still built. So let's say S, then ignore string S. Clear that out. Do a build again. Okay. And of course, we ran, sorry, the process was locked. We ran our build, we ran our tests, we're going to submit a PR. The last thing, of course, we forget to do is check the documentation as we do. And if I now run the same code again, and like an echo of the exit code, going to do the same little dance. But it gives us error code 1, and it was unable to process the scripts, so it was unable to evaluate our test script. And then our documentation is no longer in sync, and we cannot get our pull request merged if we ensure that we're not, we can fail on this error code X. And then the test over here, you can already see it, that the IDE tells us, but we just didn't thought about updating the documentation. And if we now put in an empty string, build that again. Our documentation now built, I could go to 0. So just one last time, let fun do like a watch. And so we don't have any menu item for this. It's even here. Good. So yeah, this is our updated code, and that all worked out. And if it didn't, if we were to forget it, then the documentation would have failed at the build. And yeah, that just really ensures you that everything is still fine. So yeah, just writing examples like this with your actual produced binary in scripts is just really so helpful. It will stay up to date. And yeah, it's just something I really encourage more people would do, just to give an idea of how users should use this. I didn't really do this for Helpline because in this specific case, it's a command line tool, and yeah, the recommendation is to run help and see what options are there. So not the best example, but there definitely are other projects like Phantomist where we really elaborate how you can do it. For example, we have like a thing about generating source code, this full screen, and this is also just a script. We are using the binaries, and if we, for some reason, break the API, then we'll at very least know that the docs are not generating anymore, and that might be a red flag. Oh, we're actually breaking the public API, so we should be aware of what we're doing there, or we should reconsider with what version we're going. So yeah, it's really very, very useful. And those are my 6.5 clever things. Thank you very much.
Thank you very much, Florian. Seems you took also pretty much time for preparing it. So thank you very much for taking your time and showing this to us. This is always very, very great to look at what you are doing, and it's really cool. Yeah.
Thank you, Florian. Yeah, I have to say that every time I need to do something with the scripts, I always see Florian's repo on GitHub, because he always have really good scripts and really good stuff with Fansoma. So yeah, I encourage people to see Florian's repo and to see what's there.
Thank you.
So yeah, that was the session for F# tricks, tips, and tactics. Yeah, was cool stuff. I think I didn't know. Yeah, the scripting is really a point that also might be really cool for beginners to dig into, or maybe if someone wants to contribute to contribute in that part, could be a nice idea and maybe some low-hanging fruits. Yeah, Dave, maybe you can show us on your when was the date for your advent calendar?
25th.
Okay, 25th. Yeah. So yeah. I'm really looking forward to this 25th. How you did it. It looks really nice, and I mean I'm pretty sure it will make it in the F# repo, I guess. Yeah. I mean such cool stuff. I hope, will be available for everyone.
One way or the other. There will be definitely a way for everyone to use it with just the NuGet. If we can make it part of the official FSI, cool. But if not, yeah, you can still use it.
Great. All right. So I say thank you to everyone. If there are no questions, I would say we close the session. Have a nice weekend. Thanks for watching, and until next Friday.